few more examples of inverse function theorem, and just remember that we need to find the derivative of f inverse at a point. You need just to know what is this formula. It's 1 over f prime f inverse of the same point. Now, for example, here f inverse prime at 1, just write that and you will see that this will give you what you need. Here, I'm looking for f inverse of 1. So I need to find a value of x, which f of x sends to 1. And you see that if you look at here, that's 4. F sends 4 to 1. So f inverse will go backwards. So f inverse of 1 is going to be 4. So we have 1 over f prime evaluated at 4. And as you can see from here, f prime at 4 is equal to 2. So I have 1 over 2. F inverse prime at 2, this is 1 over f prime at f inverse of 2. And that is 1 over. What is the value of x which is sent to 2 by f? So you see here, that means that f inverse of 2 is going to be 1. So f prime, evaluate that 1. And well, if prime at 1 also, we know the table is giving that, and that is 1 over negative 3. For this one, quickly, I will do this one, f prime of f inverse of 3. And we see that 3 is sent to 3. Oops. Then f inverse is going to go backward and send 3 to 3. So it will be 1 over f prime at 3. And f prime at 3 is, you look at here, it is 4. So 1 over 4 is the difference. For 4, I already see that I need to do this. But what I notice here is that, okay, so 1 over f prime of f inverse at 4 is f prime at 2. F prime at 2 is 0. This part, the denominator, is 0. In other words, f prime of f inverse of 4 is 0. And the inverse function theorem says that, well, for those values, I don't have anything. And indeed, for the values for which f prime, f evaluated at f inverse of that value is equal to 0, the function f inverse is not differentiable. So it means that f inverse prime at 0 is not defined. So the derivative at that point does not exist. So the f prime, f inverse prime is not defined at that